So hello dear students, in this video we will see the numerical part on kinematic indeterminacy and all you can say the degree of freedom. Okay, so based on that previous video or the concepts on kinematic indeterminacy, we will solve these questions. So what is the number of independent degree of freedom for this beam? This is your roller support again, and this is a fixed support. Okay, so we know beams are considered as 2D rigid jointed open frame, and for that case the dk value will be 3j minus re, and j is the total number of joints, okay, including unsupported joint or supported joint or your hybrid joint or your um, rigid joint, okay, and re is the number of external independent support reaction. Okay, so for re for roller support is 1, and for this re is 1 again, and for this fixed support we are having re value is 3, one horizontal, one vertical, and another one is moment. Okay, so re is equal to 1 plus 1 plus 3 is equal to 5, j is equal to 3, 1, 2 and 3. So dk value is 3 into 3 minus 5 is equal to 4. Okay, so by this way you can determine your degree of freedom. Calculate the kinematic indeterminacy for this frame. Okay, so this is your internal hinge here at B, and this is a fixed support, and this is a hinge support. Okay, so re value for this a support is 3, one horizontal, one vertical, and another third one is moment. In support we are having re value as 2, one horizontal and one vertical. So 3 plus 2 is 5, re is 5. Number of joints we are having 4, 1 2 3 4, and RR we know this is our hybrid joint, or this is our internal hinge, and for this case, as this is our 2D rigid frame, so RR value will be calculated as summation of m dash minus 1. What is this m dash? M dash is number of members meeting at this hybrid joint. So one member BC is meeting at this hybrid joint, and another member AB is meeting at this hybrid joint. So 1 and 2, two members are meeting at this hybrid joint, so 2 minus 1 is 1, so RR value is 1. Okay, so dk value will be given as 3j minus re plus rr. Okay, as your release reaction is also considered here. Okay, so 3 into 4 minus re is 5 plus rr is 1. Okay, so dk value for this 2D rigid frame is 8. Okay, so move on to the next question. Calculate degree of kinematic indeterminacy considering beam as flexible. Okay, so this is your a hinge support, this is your internal hinge B, and this is your fixed support C. So we know re value will be 2 for here and 3 for here. So 3 plus 2 is 5. And number of members, axially rigid members, we are not having in the question. Our beam is considered as flexible. So m double dash value means our number of axially rigid members. So we don't have any axially rigid members. AB and BC are flexible here. So m double dash value is 0 here. So RR value will be calculated as summation of m dash minus 1. So 2 number m dash value is AB and BC. So one member, two members. So 2 minus 1 is 1. So dk value will be calculated as 3j minus re minus m double dash plus rr. Okay. So by putting all these values, number of joints is 3, 1, 2, and 3. So 3 into 3 minus re is 5, m double dash is 0, rr is 1. So dk value is 5. Move on to the next question. Rigid jointed frame shown in figure. Find the degree of kinematic indeterminacy. Okay, so this is our fixed support, this is our hinge support, and this is our guided roller support. Okay, we know for this guided roller we are having two reactions. One is vertical and another one is your moment. So two here, and for hinge support we are having two reactions, one horizontal, one vertical. So 2 plus 2 is 4, and for fixed support we are having three reactions. So one horizontal, one vertical, and another one is moment. 3 plus 2 plus 2. So total RE value is 7, and number of joints is equal to 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And M double dash value we are having axially rigid members. Okay, so for this rigid jointed frame, these beams are considered as axially rigid beams, or regularly rigid members. So as this is our rigid jointed frame. Okay, so for the rigid jointed frame we are having this beam and this beam and this beam and this beam. So number of beams are axially rigid as 4, 1, 2, 3, 4. So axially rigid members are 4 here, and dk value will be given as 3j minus re minus m double dash plus rr. So 3 into number of joints is 9, re is 7, minus m double dash is 4, and rr value is 0 because we are not having any hybrid joint, or we are not having any internal hinge here. Okay, so rr value will be 0 in this case. So 27 minus 7 minus 4 is 16. Okay, so this is the displacement component at this frame. So how it is 16. So you know, for fixed support we are not having any degree of freedom, so 0 degree of freedom here. And for this, so this joint we are having 3 degree of freedom. One is horizontal, another one is vertical, and another one is a moment. Okay, and for this joint we are having 3 again. This is your horizontal, vertical, and moment. So 3 and 3, 6. And for this joint we are having, as our beams are axially rigid, so here the beams cannot be displaced in x direction, so we are having only two displacement component. One is horizontal, one is vertical, and another one is your moment. And similarly here, one vertical and another one is your moment, because our beams are axially rigid. Okay, so beams cannot be displaced in x direction, so we are not considering here x component. Okay, so 2 here, 2 here, 3 here, 3 here. And similarly we are having only two displacement components, again two displacement components. And we know for this guided roller we are having our displacement component in x direction, because our guided roller carries reactions in vertical and again in moment, so it is displaced in x direction. Okay, and for here in support we are having only moment as displacement. So these are all our 16 displacement in this 2D rigid jointed frame. Okay, so hope it is clear. Move on to the next and last question on of this kinematic indeterminacy. So for 2D rigid frame, find the degree of kinematic indeterminacy and show all the displacement component at every joints. Okay, so here number of joints is equal to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is your unsupported joint. And we know the significance of joints means total number of joints means supported joint, unsupported joint, or rigid joints, or your hybrid joints. Okay, so this is an unsupported joint, so we are considering as a joint here. Okay, and re value will be 3 here, 2 here, and roller 4 is 1. So 3 plus 2 is 5 plus 1 is 6. So number of axially rigid members m double dash is equal to 0. Okay, as we are not having any hybrid joint here, or we are not having any m double dash means your number of members or rigid, axially rigid members. Okay, so we are not have considering your number of members which are rigid here, so we are considering all the members, all the beams as flexible. Okay, so for flexible we are not considering m double dash value. Okay, so as if I'm considering beams as rigid, so our m double dash value will be something. Okay, so here, as all the beams are rigid or all the beams are flexible, sorry, so m double dash value is 0. And RR value is 0 again, because we don't have any internal hinge for this 2D rigid frame. Okay, so we are not having any RR value here. And DK value will be given as 3J minus RE minus M double dash plus RR. Okay, so you can refer the number of joints are 10 minus RE is 6. M double dash value is 0, as we are considering our beams as flexible, not rigid here. Okay, so you can write it on the bracket. Beams are considered as flexible here. Okay, so we are not considering the beams as rigid, so that's why m double dash value is 0. And RR value is also 0, because we are not having any internal hinge or your hybrid joints, okay, on this 2D rigid frame. So 24 is a DK value, and show them in the displacement components. So for fixed joint we are not having any this degree of freedom. So for this joint we are considering three displacement. One is vertical, another one is displacement in x direction, third one is your moment. Similarly for this joint, three joints here. And for similarly for this joints, as our beams are flexible, so our displacement in x direction also, so 3 here, and displacement in x direction in the same manner, so 3 here again, and 3 here again, 3 here, 3 here. Okay, and for this roller support we are having only two displacement components. One is your horizontal part and another one is your moment. Okay, so total displacement components we are having 24. 3 3 3 3, so it is 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, So by this way you can show them in the frames also, okay, the displacement components in the frame. Hope it is clear to all of you. So thank you so much. Thank you.